Okay, so we found the time for that stone with the slingshot, and then the last part wants to know what would be the maximum height. So you're going to use delta dy max, and you're going to use your half time. So it'll be delta dy max is equal to VI, which was 12.5 meters per second, sine of your 33.22, and then half of this guy. So 0.698, I believe, is the half time. And then that'll be plus 1/2, negative 9.81 meters per second squared, 0.698 seconds squared. And when you do this, you should get a delta dy max of 2.39 meters, I believe. Okay, so that's the 2 in the textbook finished. Now I also asked you to do on the sheet. So this sheet, projectiles fired at an angle. I'm going to assume number 1 was easy because it was just ground to ground. You start off with finding the half time and then doubling it and then finding the height and the range. But I think number 2 maybe could have messed you up. So let's take a look. We had started number 2 the other day in class and we didn't get very far. So in number 2, going up, coming down, and it tells us it's caught at exactly the same height. It tells us we don't know VIX. We know AX is 0. We know delta DX is 60 meters. It lands 60 meters away. And we know the time is 3 seconds. So under this guy, VIY, we know it's VI sine theta. We know AY, 9.81 meters per second squared. We don't know delta dy max, but we're asked for it, I believe. And we know the time up will be 1.5 seconds. So using our little up trick, we can do AY is equal to VFY minus VIY over delta T. And if we're doing up, then this will be TU and this will go to 0. And from that we can find our VIY. So negative VIY will equal AY times delta TU. So VIY will equal negative, bring it over from there. This is down, this is up. So the 9.81 has to go in as a negative as well. And the time is 1.5 seconds. So VIY will equal positive, and it'll be what, 14.715 meters per second. Works out to be positive, so it's up. But the question wants to know how far in the air will it go. And so then we would do delta dy max is equal to VIY delta TU plus 1/2 AY delta TU squared. So delta dy max will equal, we just found 14.715 meters per second. Our TU is 1.5 seconds. 1/2 negative 9.81 meters per second squared, and 1.5 seconds squared. Okay, and so when you do this, you should get, first term is 22.072 meters, second term is 11.036, and it's subtracted, so delta dy max is 11.036 meters. Okay, so that's it for number 2. And it may have screwed you up just because I gave you the 60 meters and you didn't even need it. And that's because I meant to put a part B in that said what was the VI. And so you could have found the VIX from this piece, and then you'd have the VIY that you already found. And then it would have been easy to find VI and theta, except I forgot to write that as part B. I'll change that for the next time I use the sheet. Number 3 is the other one I asked you to do. And this time I tried to make your life easy by telling you the vertical component and the horizontal component. So it's being fired at an angle, but instead of giving you the VI, I gave you the VIY was 490 meters per second, and I gave you the VIX as 600 meters per second. So I actually just allowed you to not have to find the components. and it's going to go up and come down. And it wants to know how far up did it shoot. So you're looking for delta dy max again, and then how far forward. So in the x direction, our Vix is 600 meters per second. Ax is 0. Y direction, VIY, 490 meters per second up. AY, 9.81 meters per second squared, and that's down. And so the question wants to know what's delta dx for part B and what's delta dy max for part A. But before we can find either of those, we have to find delta t and delta tu. So we'll start, as we always do when it's ground to ground like this one, start with looking at the up. So AY is equal to VFY minus VIY over delta t, and if we're looking at the up, that goes to 0. So our delta tu will be equal to negative VIY over AY. So it'll be equal to negative 490 divided by negative 9.81 meters per second squared. And that's going to be awfully close to 50, I believe. 49.95 maybe, give or take a decimal, seconds, which means TU, or T total, will be equal to 99.9. I'm sure there's more decimals, but because my video is only 10 minutes, I can't do too many more decimals. All right, so then part A wants height. So delta dy max. VIY delta TU, 1/2 AY delta TU squared. So 490 meters per second, 49.95 seconds, 1/2 negative 9.81 meters per second squared, 49.95 seconds squared. And when you do this out, take away the two terms, one will be half the other again, and the final answer is 12,002. Oh, maybe 122,375 if I have my decimal in the right spot. And then part B, the range. So delta dx, Vix delta t, 1/2 ax delta t squared. This goes to 0. Delta dx is equal to 600 meters per second, and this time you have to use the whole time, so 99. And when you multiply that out, you get 59,938.8 meters. I have to go back and check my y because I still feels like I lost a decimal. 49.95 7. Yeah, I did. This should be a decimal. I thought there were 12,237. There's a decimal here, which was where I was going to put it, and then I didn't see it. Okay. All right. So those are your homework questions. If you need number 1, let me know and I can do it, but I'm thinking it was probably the easy one. All right. So next up, what's new?